we went through Cambrian explosion. Yep. Now let's go to sort of the next, like, what is the combinatorial inflation? This is something that when we got into this, I had never
heard of,
delved into at all. So like, what is this? Let's start to unpack this.
Yeah. So combinatorial inflation is the mathematical problem that evolution faces when looking at natural selection or random mutation. So to give you an idea of how this functions, if you take a 9-character string, so 9 letters in the alphabet, those 9 characters have 5.5 trillion different combinations that they can be put in the English alphabet. So the problem becomes that as you take larger sets of characteristics and you randomly change those characteristics, it has a tendency to degrade over time, not improve. So here's an example. Let's say we take a 20, or let's take a 6-word sentence. So Richard Dawkins talks about random mutation being able to, over time, I think he uses the description of a billion monkeys typing on a billion keyboards for a billion years could eventually write the works of Shakespeare. I may misattribute that to Dawkins. It's somebody else that says that. But Dawkins then a lot of times uses this phrase, methinks it is like a weasel. It's a 6-word sentence containing 28 English letters. The problem is it occupies an isolated point in space of 10,000 million possibilities. Okay. That's a very large number. The way combinatorial inflation works is in that 6-letter or 6-word sentence, if I start to randomly change letters in each of those words, the odds that I degrade that sentence over time are drastically greater than I improve that sentence. Okay, what combinatorial inflation proves, it's a mathematical probability theorem that proves that over time, random mutation degrades almost improbably.
Not improves, yeah.
Yeah. And so you're talking about a 6-word sentence. How long is the human genome? I believe it's 30 million sets. And these sets are highly ordered, specifically ordered. So if they're not in the correct order, they don't function the way that they're supposed to. So we're going from a 6-word sentence to a 30 million letter combination. What are the odds that random mutation of those 30 million bips increases? Well, we just gave you the odds. We gave you the odds on a 6-word sentence, which is 10 million possibilities.
Yeah. So add several million of those to that, right? Yes.
You're talking, right? 5 million times 5 million.
Yep.
So the probability becomes so astronomically improbable that there is no way that anybody can face that rationally.
Mm-hmm.
And so that just goes to show again that the creative mechanism, which scientific materialists want to posit, which is, random mutation and natural selection, we now know through mathematics is improbable. Never would happen. The probability becomes so significantly dismal that it's almost stupid to argue the opposite of.
Yeah.
So, okay, then another topic here I think is super important is the mind of man. Okay, so in a purely scientific process, having a brain as a product of random mutation and natural selection kind of flies in the face of what's called epistemology. So epistemology is man's ability to comprehend rationally the universe around him. It's our ability to have knowledge, essentially. So existentialists identified what's called the death of God at the hands of scientific materialists for the principal reason of the angst that many modern people experience and that they themselves felt, right? So that quote by Bertrand Russell about all of man's achievements being crushed inevitably in the slow death of the solar system is kind of the angst that they're talking about in scientific materialism, right? Is that there is no point to this life. Sartre, who was a French philosopher and I believe a bishop, said, no finite point has any meaning without an infinite reference point. And so what does he mean by that? He means that we as finite beings here really have no meaning if we're not looking to something that is infinite, which would be life after death, right? For a religious perspective. And if this life is all we've got, then what is the meaning, right? Nietzsche said that the death of God would bring about destruction and nihilism, which I think we see pretty prevalent in today's society. You know, because we're in this environment today where the death of God is a real thing. We're trying to pull him out of schools and off the dollar bill and from, you know, any practice of politics, or, you know, we essentially want to get rid of God. We're rewriting history. Science is saying that, you know, it didn't come from religious axioms. People are arguing that, you know, religion is the great perpetrator of evil throughout all history. I mean, on and on and on and on. And so it's like, you know, there's this real, I don't know, battle between the two of whether or not that makes any sense. So talking about epistemology, epistemology is the study of the basis of and justification for human knowledge. Greek episteme is knowledge and logos is reason or logic. It's one of the four main branches of philosophy, which are metaphysics, logic, ethics, and epistemology. Theism solves some of the tough issues related to epistemology. Since the Enlightenment period, philosophers have found it difficult to justify a belief in the reliability of the human knowledge of the physical world. So how do we know that our perceptions of reality are accurate? So you and I are sitting here having a conversation. How do we know that this is actually happening? That our perceptions of this are accurate? How do we know that we're not in a simulation? This isn't the Matrix, that you're dreaming?
Deductive reasoning.
Okay. So if deductive reasoning is what we have to use and that's how we operate, then you can see that, you know, it's not empirical. And this is the argument that science makes. So many of the neo-Darwinists, scientific materialists deny the reliability of the human mind or our ability to form accurate representations of a mind-independent world around us. David Hume initiated much of this skepticism in the 18th century. So he posited that the laws of nature were learned primarily through inductive reasoning. Example would be observing a ball falling to the ground after lifting it and then letting it drop. We infer that all suspended bodies fall. But Hume pointed out that such inferences are inevitably based upon a limited number of observations and cannot be proved empirically. We have to rely on the inductive reasoning to posit the uniformity of nature. To try and prove the uniformity of nature, we use past and present experiences where suspended balls fell. Inductive reasoning. Circular logic or justification. Hume's conclusion: we cannot trust our ability to know the world around us. This problem, identified by Hume, the problem of knowledge, raises the fundamental question of the reliability of the human mind. By showing that the uniformity of nature could not be justified by an appeal to repeated sense experience, Hume actually showed that the human mind assumed such uniformity. But since Hume shows that the assumption could not be justified empirically, he doubted our ability to know the world around us. Many other neo-Darwinists followed this thought process. How then does one act if the mind cannot be trusted and the uniformity of nature cannot accurately be deducted? So, to work through that in a simpler way for anybody that's listening to this, because that's kind of a complex sentence there. What Hume is arguing is that when we look at a ball fall, a suspended object, and we make an inference that all spherical, non-suspended objects fall, we essentially are saying that there is uniformity to nature. But we haven't exhausted all experiments of balls falling in nature. And so it's not an empirical fact. It's inductive or deductive reasoning that we've utilized to draw that conclusion. Now, to prove that conclusion, we're going to go back and look at spherical objects falling in the past, spherical objects falling now, and then posit that in the future, spherical objects will fall. Well, we used inductive reasoning to come to the conclusion, and then we used inductive reasoning to prove the conclusion. So we're in this circular logic of inductive reasoning where nothing is empirical, which is what led Hume to say we can't actually trust our mind because our reasoning is not empirical. It's inductive or deductive. And so then what happens is you say, okay, the human cognitive ability, because it came through this random mutation and natural selection and can't actually be empirically proven, is not able to be trusted.
How do you reconcile the idea of proof versus absolute truth?
Yeah, so this is an interesting dynamic here where theism plays a pivotal role. So if Hume believes that he cannot trust his mind, how does he operate on a daily basis?
In fear, in doubt.
Of everything that he does? Of every instance of anything around him? Well, the truth is that would be paralyzing. You actually wouldn't operate.
Yeah.
But Hume did operate. And so what do you see? The actions of Hume are contrary to the beliefs of Hume.
Yeah.
Because all beings, scientific or not, operate as if the world or nature has uniformity,
Mm-hmm.
right? That would be like us getting up and brushing our teeth because we believe that brushing your teeth is going to preserve your teeth. When it's dark, we hit a light switch because we believe that will turn on the light. We get in our car, we start it because we believe that starting a car is
turning a key is going to turn it on.
Is uniform.
Yeah. Yep.
And so we operate, every being operates as if nature is uniform. But neo-Darwinists, scientific materialists, people like Hume, they don't believe that. But they still operate that way. And so what does that create? It creates an insane level of cognitive dissonance, believing one thing and doing another. What do we call that in real life? If a person says something and does something else.
Hypocrite?
Yeah, they're a hypocrite. So this belief system is hypocritical in the very nature of how the people that believe it act. Take it one step further. You want to see how stupid this is? Hume makes an argument that we can't trust this, right? We can't trust our ability to empirically define anything. Do we trust Hume's argument? He invalidates his own argument by his argument.
Yeah.
So anybody who wants to say that we are this random mutation, this collocation of atoms over time, that we can't trust our faculties because they're not from a rational designer, defeats their own argument by saying we can't think rationally.
Yeah.
Well, then why is your explanation to be trusted of the rational thought process of man? Can you see the insanity of that proposition?
Mm-hmm.
But what's interesting to me is that so many people subscribe to this ideology. But if you just walk through it logically, you take a few steps into it and you start to realize that this descends into absurdity. Because what you've done again is you've put this on an infinite spectrum. You've essentially said that the human mind is not a rational thought process in a box here. It's an irrational mind that can be anything. Could have come from anywhere and completed by any process. It's random. Well, then it all degrades into chaos. Now, theism is a great counter to that argument, because what does theism posit? Theism posits that we were designed by an intelligent designer who gave us rational cognitive abilities. He was a rational designer. He put a rational mind in us, which means that the uniformity of the world around me is rational. And I would expect, if it were designed by a rational God, that I would find uniform laws of nature in nature. This is what drove Copernicus, Galileo, the early scientific, revolutionists of the Enlightenment period, was that they believed that the uniformity in nature was there because it came from a rational being. If we believe that our mind is irrational and can't be trusted and came through random mutation and natural selection, shouldn't we find the same random natural order in the universe? Richard Dawkins makes the stupidest statement I've ever heard. He says, we find in nature the, what does he say? We find in nature essentially what looks to be design, but it's not really design. It's like, what does that even mean? It looks like design, but it's not design. How does that function? You tell me. Find me something that looks like design that is not design.
Yeah. Interesting enough, there's rational thinking that goes into the idea that you're choosing to be rational with certain parts of your life, but irrational in other parts of your life. Right. So, i.e., when I put this pen on this paper, that's a rational thought that I believe that it's going to write something.
Yeah.
But I'm going to be irrational about certain other points, like all of this has no meaning, or if I choose to kill somebody, it has no consequence. Or
you are acting rationally, but positing an ideology that is irrational.
That's right.
And so what theism does is it posits a rational ideology that allows your actions to be congruent with your thought process. And this in life is how one wins, is when who they know they should be is aligned with how they act. But when we know something and we don't act what we know, we create this cognitive dissonance, which brings anxiety and all of these other negative emotions because it's entropic in nature. For one to believe something and act counter to that belief either destroys the belief or the act.
Mm-hmm.
One has to win. Those two cannot be competing. And that's why you find people like Friedrich Nietzsche, who said that the death of God would lead to nihilism and destruction, killed himself because he had to align his actions with his thought process. And what that ended up was that his actions won. He was congruent with his thought process, credit to him. But if that's the route you want to go, then what's funny to me is this. So science wants to posit that religion is false. But when following the rational thought process of science, it leads to cognitive dissonance, higher rate of suicide, which would ideally show that the evolutionary process favors religion. Because there's empirical data to show that religious people are happier, they live longer, they have more children, which means that their ideology perpetuates ongoing. So it's interesting to me that the scientific argument basically shows that
so counterproductive. Yeah.
To think that way is actually through natural selection going to destroy anybody that believes this thought process. And that's what's so funny is as you extrapolate this out into society, you start to realize the insanity of the scientific naturalist thought process. And it's like, why then wouldn't one posit that theism is a better explanation or a better way of operating than scientific materialism? Because to not be able to trust one's faculties and act like it, and then eventually lead to nihilism and destruction and the killing of oneself. I mean, listen, if that's what you want to believe, go for it. But natural selection is going to weed you out.
Mm-hmm.
And eventually all that's going to be left is people who are congruent with how they think and act. And the only way to do that is to believe that there is rationality to the universe that came from a rational designer that gave us a rational mind to comprehend the rational aspect of the universe around us, back to the religious axioms that science is based on. So it's based on religious axioms. You can act like you think differently, but your actions of finding and discovering rational truth in the universe are belying what really is the truth of the thought process that needs to be equipped in order to be a good, productive scientist.
Yeah.
So I find that super interesting.
I do too. Before we move on too far away from Darwin's theory of evolution, and then we're going to get into the human cell, which I think you and I are both
still part of Darwin's theory of evolution.
Yeah. So there's a couple of things that we haven't touched on that I would like to just quickly, and we may get to some of these as we go, but there's a video that we'll link down below that I think is one of the most productive hour-long discussions around the theory of evolution. And it was a video between three, pretty incredible scientists that talk about, it's a Hoover Institution video about the mathematical challenges to Darwin's theory of evolution. And it's a discussion between David Berlinski, who you've referenced before, Stephen Meyer, and David G. Gelenter, which is moderated by Peter Robinson. Yep. Okay. And Behe does some separate work that's obviously really good. So there's
another great one from the Hoover Institute that is Behe, Myers, and
Berlinski?
No, John Maxwell.
Oh, really?
Yes.
Yeah.
So
that's money.
Theoretical physicist, geophysicist, and microbiologist.
Yeah.
Which is brilliant.
So the 3 points, there's several that are covered, but the 3 that I found really interesting, which were the following, right? So the rarity of functional proteins, which we're going to get into, the human cell and proteins and how these things operate. But it's the idea that there's an improbability of random mutations leading to the formation of functional proteins.
Again, that's combinatorial inflation, right?
Yeah. They argue that functional proteins are extremely rare in the space of possible amino acid sequences, making the likelihood of them arising by chance almost zero.
Impossible. Combinatorial inflation. Yep.
Complexity and information. So
origin of information.
Yeah, the issue of information complexity, particularly the origin of vast amounts of genetic information necessary for life.
Yep.
That information content in DNA points to an intelligent cause rather than a random mutation in natural selection.
Yep.
And then mathematical models.
Yep.
So that mathematical model is used to support Darwinian evolution. They argue that these models often fail to account for the complexities and specific conditions required for evolutionary changes to occur, thereby overstating the plausibility of Darwinian mechanics.
Yeah.
Right.
Yeah. So that is a great segue into the start here, because some of the mathematical models that were posited early on, what were the beliefs of people in Darwin's day about the human cell? Well, one of Darwin's trusted confidants that, he cites in Darwin's book, The Origin of Species, said this about the human cell. The simplest form of organic life is not, as commonly stated, a cell, but a microscopic lump of jelly-like substance or protoplasm.
Gosh.
Protoplasm, which we now call cytoplasm, and know to be full of cellular organelles, molecular machines, RNA molecules, enzymes, and numerous other crucial biomolecules, is considered by Darwin's favored authority on the subject to be the simplest form of organic life, which is a microscopic lump of jelly-like substance that is destitute of texture and destitute of organs with no trace of organization.
That one did not age well.
No.
Like not that long later.
And that is the premise for Darwin's theory of evolution.
For sure.
It's like, how does one defend that scientific premise?
Yep.
When we look at what modern science has to say about the human cell. I mean, listen to just a few of these statistics here. Each of the 37.2 trillion cells in the human body is like a whole city of biological activity. In terms of compressed complexity, cells are without peer in the material world, actualized or imagined. What does that mean? In level of complexity, there is nothing in the known universe as complex as the human cell. How is that in dichotomy to a microscopic lump of jelly-like substance destitute of texture or organs with no trace of organization? We now say it's the most complex thing in the entire observable universe. There is much more to discover about the cell, but even from our current limited knowledge of its depths, it is clear that this tiny unit of compact adaptive sophistication constitutes something like a third infinity, where the cosmos feels infinitely large, the atomic realm infinitely small, the cell feels infinitely complex. Come on, Darwin.
A single cell.
A single cell.
30 to 40 trillion in the human body.
Yes. And then we can get into some of this, right? So the unique fitness of the cell to serve as the fundamental unit of life is also manifest in its amazing abilities and diversity of functions it performs. Even the tiny E. coli, a cylinder-shaped bacterium in the human gut, has spectacular capabilities. Howard Berg has marveled at the versatility and capacities of this minuscule organism, calling its talents legion. He notes that this tiny organism, less than 1/millionth of a meter in diameter, 2/millionths of a meter long, so small that 20 would fit end to end in a single rod cell of the human retina, is nevertheless adept at counting molecules of specific sugars, amino acids, or dipeptides, at integration of similar or dissimilar sensory inputs over space and time, at comparing counts taken over the recent and not so recent past, at triggering an all or nothing response, at swimming in a vicious medium, even pattern formation. So it can identify, it can count, it can move, it can act, it can, all of those things in a single one in the human cell. Cells also move in diverse ways. E. coli travel by the propeller-like action of the bacterial flagellum, which we have to talk about. Others do so via the beating action of cilia. Some creep and crawl. Some put out pseudopodia and grasp small objects in their immediate vicinity.
The craziest part about, like, as we get into things like the flagellum motor, is that it's not even a core part of the cell. It's like a
subset of a subset of a subset.
Right. It's deep into the core of the cell, right? So what is the core of the cell? I'm going to read this off.
Yeah, go through it.
So you've got the center part of the cell, which is the nucleus, which includes DNA and RNA. Okay. A copy, a machine of all the cells that will send other parts out to the cell. That's the RNA. We know what DNA is.
Yep.
There are, by the way, 10,000 errors every single day inside of a cell, but we have a repair unit in the cell that looks for errors and cuts out sections of errors to replace or get rid of it.
Yeah,
okay,
so
this
how's
is
it doing that?
part of the RNA. 10,000 errors a day inside of a single cell.
So it's categorizing. It understands error.
Yes.
It's then categorizing and removing error.
Yeah. Okay. The mitochondria is the energy factory, which I want you to talk about the ATP synthesis, which sits in there. Okay. Let's talk about that now. What is the ATP synthesis?
So the ATP synthase creates the ATP molecule, which holds the energy for all cells. So it's essentially what the ATP synthase is a battery production facility. And then it produces the molecule that is the battery that goes into all moving parts of the cell to give them energy. So you essentially have inside of the mitochondria a battery production facility that produces batteries that then are carried into other aspects of the cell and plugged into them so that they can then have power to move.
This is one of several components of the mitochondria, is the ATP synthase.
Yeah.
Okay. The endoplasmic reticulum, which makes proteins, lipids, and steroids. You have ribosomes, which are protein-making machines.
Have you ever seen the ribosome in action?
Yes.
It's freaking incredible.
Yeah.
It has all of these different parts to it. So like it's got like an assembly line system that puts the protein parts in place. It has clamps that go in and merge these two parts together. Once that protein is built, it goes through a portion of that folds the protein into the form that it needs to be to interact with the portion of the cell that it's going to.
Yeah.
It's miraculous to behold. When you read through it, it sounds like a highly functioning assembly line system that's built in like a manufacturing plant. It's freaking wild.
The Golgi apparatus, a separate part of the cell, main part of the cell, similar to a post office with a massive shipping department that packages and tags protein and fat to be shipped out to other parts.
Yeah, I think in part of that is what they call the Keynesian robotic walking protein.
Right.
This is a protein that's built like a robot that walks, and it is a delivery mechanism in the cell. It walks down a track that looks almost like a railroad track,
Yeah.
and drops off stuff to different parts of the cell that's needed. It's like a post office delivery man.
Like
So
Amazon,
he's leaving the post office with his mail, and then he goes down these tracks like roads and delivers it to the different parts of the cell that need it. And he knows what to take from the facility, where it goes, and what to give it to. It's like, how are you going to say that the cell is a simple blob of protoplasm that has no distinct organism inside of it? We're talking about a micro, I mean, it's like a micro universe.
Yeah.
That is so complex, we can hardly comprehend it. We've just scratched the surface, and we're talking about DNA that's sorting code. We're talking about systems that are producing batteries. We're talking about sorting facilities that then have components of them that are, walking through the human cell and dropping off aspects of the needed material for those to build. We're talking about forming proteins into specific shapes so that they can then be propelled by the bacterial flagellum through to where they need to go. I mean, it's just miraculous.
Well, wait till you hear about the lysosome, okay? The lysosome is the core part of the cell that breaks down waste and damaged parts to be recycled. So you can trigger this, humans can trigger this through things like fasting. Okay, so you do a water fast. One of the main things in water fasting for 48 to 72 or more hours is this cell regeneration. So it's taking, you hear this idea of you have all these bad cells that build up. How do you get them out? Well, you don't eat food, which triggers the lysosome to break down waste and damaged parts. Okay. You have the peroxisome, which makes enzymes that clean up peroxide from white blood cells that produce peroxide to kill things like cancer.
Oh, yeah. So we have our own peroxide
cleaning
producing
system.
Yeah. And then not only that,
yes,
those are going around taking that chemical out, disposing of it.
So
you
after it's done its job.
Yeah, you essentially have like a trash management compaction. I mean, we can't even figure out how to break down some of the materials that we create in the real world. When you look at like batteries that we produce and then try to reuse, very difficult.
Totally.
When we use nuclear material, we still don't know how to dispose of that. We put it in barrels and bury it. It's like, the human body's so sophisticated.
It knows how.
Yeah. It's taking care of all of the poison inside of us in its own freaking processing plant.
Yeah. Then you have, like the flagellum motor.
Yeah.
Right. Which
incredible
is incredibly sophisticated device that looks and acts like a jet turbine engine.
Yeah. So I have some information on that. Bacterial flagellum are long whip-like tails protruding from a base tethered in the cell wall. The base contains a rotary motor powered by an electrochemical gradient. A mismatch in the concentration of hydrogen ions across the membrane provides the energy needed to power the motor. The strength of the gradient controls the speed of the rotation. Typically, the propeller tail spins in the range of several hundred to 1,000 RPM. As a result, bacteria can travel up to 60 cell lengths per second. The shape of the propeller and the ability of the rotor to change direction allows the bacterium to either swim in a precise direction or randomly tumble to reorient when needed. The number and arrangement of flagella can vary dramatically by species, yielding great diversity in the way bacteria get around, but the basic unit is the same. In reality, the machine is quite complicated. Just like an outboard motor, the flagellum has a rotating element, a rotor, a stationary element, a stator, embedded in the cell wall and membrane. These elements are connected to the flexible filament by a hook. The parts list for these three components include about 40 different proteins. What's super interesting too about things like the flagellum motor, which is a rotary engine inside of us that propels cells through our system, is that it's an irreducibly complex system. So what does that mean? This is another argument against evolutionary biology. So evolution says that through random mutation over time, we have these incremental parts that are useful, that are retained, and then everything else is discarded. The problem is in something like the flagellum motor, you have an irreducibly complex system, which is made up of 40 different proteins and multiple parts. And if you take any of those parts away, it doesn't function. So that would be like, we can find irreducibly complex systems in our world. One of those that's really simple would be like a car motor.
Yeah.
So if you don't understand a car motor in a simple format, you have a block, you have cylinders in the block, you have a piston inside of that cylinder, and then on the top of that, you have valves. What the piston is designed to do is it moves up and down. It has a connection at the bottom called a rod. That rod is connected to at the bottom, it's connected to a crank. And so what the crank does is it takes an up and down motion and converts it into a cylindrical motion, which is how you get power from the up and down motion in a motor to convert into like a transmission, which spins or in a cylindrical format, which moves wheels. But so in that motor, it's irreducibly complex, because if I take the piston, which is inside of the cylinder, when it moves up, what it does is it compresses air. As air gets compressed, it's heated. We then have fuel and a spark that's injected, which creates a controlled explosion, which then moves the piston back down. It's the force of that that causes the motor to spin the crank at the bottom and produce power. Now, if I take the piston out of a motor, what happens to the motor? Well, it can't function at all because it's irreducibly complex, meaning that if I remove any part of the motor, it doesn't work like a motor. Well, the bacterial flagellum is the same way. And there are tons of irreducibly complex systems in the human cell.
Yep.
On a magnitude of, tens, if not hundreds. And so you've got things like the ATP synthase, the Keynesian robotic cell, the flagellum motor, these are all irreducibly complex systems. And so if Darwin's theory of evolution were accurate, you would not be able to have a 15 or 20 part system that all was together at the same time. Because, intelligent design allows for us to retain and keep pieces that are intelligent. But Darwin's theory of evolution says if the part doesn't function, then it's discarded. Well, how do you get 40 parts together when neither of them by themselves function? You can't.
Yeah.
Right? That's inexplicable by evolution over time. And so it flies in the face of this idea that you could get these simple systems that become complex, when in some of these complex systems, you have these irreducible complexity portions that need all the pieces together at one time to function as they're supposed to. So again, just another great argument that says, how does one continue to believe in Darwin's theory of evolution?
Yeah. David Behe, who you've referenced his work, he does this analogy where he talks about a mousetrap, right? So you talked about a car motor.
Yep.
Look at a mousetrap. It's
Even simpler.
It's a very simple mechanism.
Yep.
It's got like 5 parts on it or
Yep.
something. So you have like the wood base, you have the trapping mechanism, the spring, and then the pin.
Yeah.
Right.
The
And
release.
that's really what makes up
Totally.
a mousetrap. And he says, if you take any of these away,
Yep.
it doesn't work. And this is incredibly simple to think
Yeah.
about. Whereas when you start talking about, we're only talking about the cells, by the way. We're not talking about
We're
any
not
other
even talking about the cell. We're talking about minuscule
parts
pieces
inside of the cell.
inside of a cell.
Yeah. So if those things don't all function in unison together with order, then therefore,
Well, I think
the
you
whole
could
thing
make the
doesn't work.
argument that the cell is an irreducibly complex in its own right,
yeah.
because it has millions of parts inside of it that we now know.
Yeah.
That even those parts are irreducibly complex. So you scale irreducibly complex to irreducibly all the way up. And then what you get is something like a car, where a car doesn't function without a motor.
Yeah.
And a motor doesn't function without a piston. And a piston doesn't function without a piston ring. And a piston ring
yeah.
doesn't function without the molecular makeup of metal.
Yeah.
And so you get irreducible complexity to the nth degree inside of the most complex function.
Yeah.
And a cell makes up what? Well, ultimately, it's us. There's billions and billions and billions of those inside of us, right? So it's like, I just don't understand how one can make an argument that, this is not just so brilliant. So that's talking about the human cell, some of the complexity. We then kind of get into the DNA molecule, which is unique in and of itself because of its information-like properties, which we'll talk about. Do you have anything else you want to cover in the human cell? I know you had a lot of notes.
There's probably some stuff. I mean, it go hand in hand with DNA molecule, but I just wrote down some fun facts about the human body.
Yeah, fire away.
Which would just be kind of fun to
I'd love to hear 'em.
riff on.
I wrote some interesting facts on DNA at the end.
Yeah. So fun facts about the human body. The human body consists of approximately 37.2 trillion cells, right? And this depends on age and trillion cells. What's a trillion? Like, how many is that?
It's a difficult number. Nobody's ever amassed that wealth yet.
DNA length. If you stretched out all of the DNA in a single human cell, it would be about 6 feet long. If you laid out all the DNA in your body end to end, it would reach from the earth to the sun and back more than 600 times.
And how far is the sun? I know it's millions and millions and millions of miles. It's like 0.0009 light years, but I don't know.
The sun is 95 million miles away.
So it would go there and back how many times?
600 times.
What's 600 times 95 million? Can you do that math? 95 million times 10 would be 950 million.
This would be 57...
100,000 million, billion, trillion.
9 zeros?
9 zeros.
That's
100,000 million.
570 billion?
Yes.
I think that's the number.
So DNA is 570
billion miles long.
Wow.
Okay. Unique fingerprints. Every human has unique fingerprints, even identical twins.
Yeah.
So you think about, there's been 220 billion humans roughly that we know that have walked on the face of the earth. Nobody has the same fingerprint.
Never repeated.
Not even once. What's the odds of that? The human brain has about 86 billion neurons, each connected to thousands of other neurons, creating a vast and complex network.
We don't even understand how the human brain functions.
It generates approximately 20 watts of power, which is enough to light a light bulb.
Ding.
That's cool.
Very.
Okay. You talk about...
It's probably some of the ATP synthase batteries inside of us.
Maybe. I don't know. The fast nerve signal. So nerve impulses travel to and from the brain at speeds of 250 miles an hour.
Yeah, that's quick.
So that's cool.
Reaction speeds.
Yeah. The masseter or jaw muscle is one of the strongest in the body. It can exert a force as great as 200 pounds on your molars. I think that's an interesting one. Just a fun fact.
Oh yeah. Made me think about how hard you can bite.
So you ever heard the idea that you could bite through your finger as easily as you could bite through a carrot, but your brain will not allow you in most cases to do that?
Interesting.
Unless you were on drugs, for example, to where your brain wouldn't interpret that this is your finger.
Yeah.
Right. Do you believe that? Like you could, just as you could bite through a carrot.
Well, I've gotten a bone in food before and been chomping and
bit
just
right through
nuked that sucker.
Yeah.
So yeah, I believe that.
Ounce for ounce, human bone is stronger than steel. Okay. A cubic inch of bone can bear a load of 19,000 pounds. So you take 1 cubic inch of bone, you set on this table, and then you load 19,000 pounds of
weight. Name
the thing on top of it, and it will not break.
Yeah, that's super interesting. That means you can lift heavier in the gym.
Yeah. We talk about sensory systems.
Yeah.
So the human eye can distinguish about 10 million different colors.
They talk about the eye as an irreducibly complex system as well. You know what's interesting though? You said 10,000 colors.
10 million.
10 million colors. But did you know that we see only a trillionth of the electromagnetic spectrum?
Yeah.
So that's wild to think about.
Right. So it's like what's the math on 10 million different colors times a trillion?
In a trillionth of the spectrum? Oh, yeah. That's beyond mathematical.
Humans can distinguish about 1 trillion different scents.
Wow. Smells. Interesting.
The human heart beats around 100,000 times a day, pumping about 2,000 gallons of blood through 60,000 miles of blood vessels every day.
Yeah, that's psycho. These are just some crazy stats, man. To think that all of these things came together in a format where we function the way we do, and to think that that happened by random chance, to me is just an untenable. I don't see how one rationalizes that.
This one's cool. So, like, anytime somebody says their favorite hero is Wolverine, and I'm like, why? And they're like, because he can repair himself. I'm like, that's what we do. Like, he's basically just like us. He can do it slightly faster, right? So here's this one. The human liver can regenerate itself completely. Even if it's 75% removed out of your body, it can grow back to its full size.
Interesting.
And there's many parts of the body that are this way.
Yeah.
I think as long as there's no bone structure, you can't regenerate bone to certain levels, right?
Yeah,
so if you chop your hand off or your finger or things like this.
Yeah.
Humans have between 2 and 5 million sweat glands, and sweat is odorless. The smell is produced when bacteria on the skin breaks down sweat.
Yeah.
And then a couple of miscellaneous ones, which are fun. The human body hosts about as many bacterial cells as human cells.
Yeah, I knew that. About 37 trillion or 32 trillion or whatever it is.
So the human microbiome plays crucial roles in digestion, immunity, and even mental health.
Yeah.
Do you know how many hairs are...
Some of us more than others.
Yeah. The average human scalp...
Yeah, I think I've got less.
...has about 100,000 hair follicles. Each follicle can grow about 20 individual hairs in a lifetime.
No, that's wild.
And the human body produces 25 million new cells every second.
25 million?
And each day about 300 billion cells are replaced. So these little cities inside of us, 300 billion a day.
Wow, those are insane stats, man.
Like we talked about the cosmos, and it's like crazy to comprehend. You start getting into this, you're like, I don't know which one's like.
Well, that's that quote I gave where it talked about the third infinite, where it said the cosmos feels infinitely large.
Yeah.
The atomic realm infinitely small, and the cell is infinitely complex. Because when you think about that, like we've just scratched the surface of microbiology, but you are literally building 300 billion. Is that what it said?
A day. 300
billion of those intricately moving.
25 million a second.
Yeah.
Right now, 25 million. 25 million.
That's wild. With walking robots and rotary motors and post office sorting facilities and,
It makes you believe that if one day microbiology could get to a place where you could like potentially live forever, if you could figure out how to...
the reproduction of the cell in that way. Yeah.
Right? Because that's really why we age, is cell... Our cells dying off over time.
I read an article a long time ago about a guy who was waiting on a heart transplant and couldn't get it, was going to die. So he was part of an experimental program where they gave him a turbine heart. So when they EKG him, he flatlines always because he has no heartbeat. But they put a turbine in his heart, a titanium turbine that they said could run for 1,000 years. And he's got a turbine that's pumping blood through the 60,000 miles of veins in his body. But it's like, it's just wild to think about, Like it's so complex and so miraculous and in such a specific order that I just don't see how anybody argues anything other than intelligent design. So DNA, this is, probably one of the most, I don't know what you'd call it, but points towards information and intelligent design as robustly as any other argument we've made. So consists of 4 nucleotides arranged in specific order. This order is not just random, it is communicative information. The development of all micro machines in the cells, the formation of proteins from amino acids is all dictated and driven by the human genome and the information encoded in the nucleotide sequence of DNA. So that's what's so interesting. We just talked about DNA was how many miles? We did that whole calculation. It was 95 billion miles of DNA.
57 billion.
Oh, 57 billion miles of DNA.
Yeah.
So when you think about what DNA is doing, is DNA is giving the code to build these cities in each cell, right? And so it's no wonder you have 57 billion miles of code, because you're building 250 billion cities a day inside of each cell operating in your body.
300 billion. But
Yeah.
who's counting?
300 billion. 300 billion. 300 billion a
Yeah,
day.
you have to have that much DNA.
You would have to. Well, and what's so interesting is, did you know that I have a stat on DNA that a few grams of DNA could store the entire world's data. A few grams of DNA could store all the data in the entire world.
Make that make sense. I mean, that's just...
Well, then you think about how many grams of DNA are inside of us, how much data is stored, how complex is the system that it's producing? Irreducibly complex. Irreducibly complex. I mean, as we're getting into microbiology, it's like, yeah, you start to realize that a few grams of DNA could hold all the data in the world, and we've got tons and tons and tons of it inside of us. We're storing so much data input because we've got to build such complex machines inside of us to operate in the way that we do. Mind blowing, dude. All dictated and driven by the human genome. This coded information is unique in that we do not observe information code anywhere else in the universe unless directed by intelligence. Stephen Myers has noted, as it turns out, specific regions of the DNA molecule called coding regions have the same property of sequence specificity or specified complexity that characterize written codes, linguistic texts, and protein molecules. Just as the letters in the alphabet of a written language may convey a particular message depending on their arrangement, so too do the sequence of nucleotide bases, A, T's, G's, and C's, inscribed along the spine of the DNA molecule convey a precise set of instructions for building proteins within the cell. Our personal experience tells us information comes only from intelligent sources. In fact, in the entire history of the universe and the history of science, not a single instance of information arising from anything other than intelligence has ever been identified. This presents a problem for those who attempt to stay in the room of the universe to account for genetic information. If we limit ourselves to the materials available to us in the universe, information must be explained from matter, chance, the laws of chemistry or physics, and nothing more. Nobel-winning biochemist Manfred Egan recognized this challenge when he said, "Our task is to find an algorithm, a natural law that leads to the origin of information. Efforts to account for the information in this way have repeatedly failed. In fact, the information in DNA proves to be the decisive stumbling block for every naturalistic theory offered for the origin of life." So a few grams of DNA could store the entire world's data.
Which, by the way, so how many grams of DNA
Don't
are in
know
our
in the
body?
human body? Look it up. I'd be curious to know, because I'd like to know how many times the world's information we're storing inside of our own body.
Grams of DNA in the body. Around, 50 grams of DNA.
Okay, so we have enough to store all the information in the entire world, say 15 to 20 times over?
Yep.
I mean, a few is 2, so 25 times. We could store 25 times the data of the entire world inside of us because of the amount of DNA we have.
And which, by the way, reaches
ChatGPT on steroids.
from the Earth to the sun and back 600 times.
Yep.
57 billion miles long.
57 billion miles of specific code. I mean, you talk about an intense computer program. That is freaking wild. Our DNA is 50% the same as a cabbage. There's 3 billion DNA letters contained in every cell. The length of the book written from our genetic code is equivalent to the length of 2,000 copies of Don Quixote's de la Mancha. Even more shocking, if we proceed to write the book of our DNA, assuming a typing speed of 60 words per minute and working 8 hours a day every day, it would take 50 years. Now let's talk about lengths. A 1 millimeter long piece of DNA contains 3 million bases or letters. If we unrolled and unpacked the DNA of a single cell, we would obtain a sequence of 2 meters in length. If we unwrap the total DNA of a human being, estimated to have about 38 trillion cells, its length would be more than 100,000 million kilometers, and it would weigh only 0.18 grams, an extension equivalent to making about 26,000 trips from the Earth to the moon.
Yeah.
Side note, possible combinations of DNA, 10 to the 600,000th, yet it's in a specific order that functions perfectly the way it does, that produces these micro cities inside of our cells that can do all sorts of incredible things. And we want to believe that all of that came from Darwin's theory of evolution. I'm not sold, Tyler.
I tend to agree. That was a lot of fun.
Yeah.
Do you want to bring us home? What's your recap on what we talked about today?
Yeah. So here's my recap. If you are a scientific materialist, you clearly recognize that we are biased in our argument, that we're coming from an intelligent design perspective. But I would say do this. Try and objectively look at your feelings about being a finite being in a world that has no meaning. Not being able to trust your mental faculties and being destined to be destroyed in the heat death of a slow dying entropic universe, versus the grandeur of being the crowning creation of an intelligent designer who put together a rational universe and gave us the ability to comprehend it so that the way that we think and how we act could be congruent, and we could magnify those gifts and abilities, and through that discover the unique uniformity of the world around us, the complexity of the human cell inside of us, and take the intellectual capability of the rational human mind to just places we never thought we could go. Man is an incredible being. He is order in a universe of chaos. And I think he is miraculous. He's divine. One of my core beliefs is that we are all children of God and that we possess divine qualities and infinite potential. We have glimpsed a small bit of the infinite potential inside of man. His ability to comprehend the things around him and the complexity of what makes him who he is. I don't see how scientific materialism, Darwin's theory of evolution, neo-Darwinism, has any positive competing aspect to theism and the beauty that it brings in life, in our way to operate, in the happiness and joy that we feel, in the ability to find lasting hope in the future, because we're a finite being that needs an infinite reference point. And without that, there is no meaning. And so what theism brings is the infinite reference point to us, the finite point here on earth.